Okay, at the beginning of the hour, we gave some time to correct homework and work on homework. And just now, I asked the people who are in the room if they wanted to do example 2, where we sketch the graph of y equals arcsine x. And everybody agreed that they have that in their notes already from the other day. So we are not going to do that one. We're just going to move on to our next problem as we go through that. And that is going to be to look at other inverse trig functions. And so I'll leave that graph on the slide so that you can see that if you want to look at it. And oops. Other inverse trig functions is what we're going to look at next. And we talked in detail about this yesterday, so these shouldn't be really earth-shattering news for us. And we'll have a slide that kind of puts arcsine, arccosine, and arctangent all on one thing. So cosine we talked about to make it one-to-one and pass that horizontal line test. We're going to go from, in this case, 0 to pi. And so that's where cosine is one-to-one, and it's decreasing that whole time. And again, it's called either the arc cosine or the inverse cosine as we look at that. And then inverse tangent, and they just kind of give a very short blurb here about inverse tangent. But if you remember, tangent has asymptote at negative pi over 2 and pi over 2. And oh, and between those, you have that full graph. There, your negative 1, 1, and 0. You have that full graph that looks like that. One thing I'm going to point out, and I'll point it out here first, when it's in interval notation, because these are the asymptotes, those are not included, whereas for sine and cosine, they are included. And so that's just something to be aware of because it's undefined at those places. So then here is the definitions of the inverse trig function. So this is where you want to kind of just make sure you have everything. So y equals the arcsine of x if and only if sine of y equals x. And so that's what you're looking at, the angle versus that ratio. And notice it's bound by negative 1 and 1, including those. And it goes from negative pi over 2 to pi over 2 for arcsine. And I'll add to that one that this is where all students take calculus. And for sine, we omit these two. So all of our answers for arcsine problems are from 0 to pi over 2 or from 0 to negative pi over 2. So we get kind of those positive and negative values. Then y equals the arc cosine of x if and only if the cosine of y is equal to x. Again, from negative 1 to 1, from 0 to pi for this one. So here all students take calculus. I maybe made that a little too big for sine, but for cosine or arc cosine, we're using the first 2 quadrants. So this one is a little trickier. We have to find the reference angle, especially if it's a negative. We have to find the reference angle and use that second quadrant as we go through this, and I'll kind of color code those as I go. Then arctangent, and kind of thinking about that. For arctangent, all students take calculus. For that one, again, you're going to use the first and fourth quadrant. And so your angles will either be from 0 to pi over 2 or from 0 to negative pi over 2. And then I just wrote myself a little note for the range for arctangent. We're not including the endpoints, those endpoints. Oh, I'll try to spell endpoints correctly. Because that's where there are asymptotes, and the tangent is undefined in those. I also wrote myself a little note on this, and that is just a reminder with this domain for sine and cosine being from -1 to 1. If they ask us a question, and this threw us off a little bit yesterday, um, I won't write y equals. If they ask us what is the arc sine of like 7, that is equal to no solution. And I wrote a hint to myself on that because sometimes we kind of get caught up in figuring all this out and we kind of forget that it's bounded by that positive and -1. And then here are those different functions. You've already graphed the arc sine. If you want to try and graph the arc cosine, it goes from -1 to 1 on the x-axis and from 0 to pi on the y-axis. It's a little easier, I think, to graph than arc sine because you'll have a point at 1, 0, a point at 0, pi over 2, and then a point at -1 pi, and then it's a little easier. And then the domain and range are given in interval notation, and likewise with the arctangent, um, that one has the asymptotes now are horizontal asymptotes, and the key points I would put in there are at 0, 0, -1, and kind of halfway between here and pi over 2, negative +1, and kind of halfway between there and pi over 2, because that's at pi over 4. So take a minute and just at least get yourself a sketch of each of those. So I guess during these pausing times, I could have or work writing times, I could have paused it. So I will in a minute. But I'll announce for those of you who are gone today that we're having a little self quiz. And so I will pause it while people who are in the room are going to just generate the table. So I gave you a blank sheet of paper. If you're here, take a minute and generate that table, and then I'll come back on. I'm happy to report all of your peers could write the table themselves. Um, just some other things. So most of our answers come off of here, but we will practice when that is not the case. But if we start with anything related to things on this table, we're going to use that. We're going to always use this all students take calculus. And then also just these quadrant angles, just keep in mind, like, if this is 1, 0, 0, -1, that's cosine sine. So if you're given ones, zeros, and -1s, to kind of think about where they are. So we're always going to be looking at our chart to find a reference angle, we're always going to be looking at all students take calculus to figure out what quadrant it is to get the actual angle. And then here's our problems to kind of try. Um, and when it says find the exact value, you can, I mean, you could use a calculator, I guess, but we want our terms, our answers in terms of pi. And by the way, we always, for inverse functions, we always use radians. So our first one is the arc cosine of the square root of 2 over 2. Excuse me, I almost didn't say over 2. And so all students take calculus. Which two quadrants is arc cosine using? S and A. Yep, those are the two that we're allowed to use. And which one is it going to be because it's positive square root of 2 over 2? A. So that's just all we have to decide there. Since it's in that first quadrant, the reference angle and the angle are the same. And what is the, I'll call it the reference angle right now. What angle in radians gives us the square root of 2 over 2? Pi over 4, and you have that in front of you if you need to look at that table. So the arc cosine of the square root of 2 over 2 is equal to pi over 4. The next one, and that's just kind of how we go through this. Next one is arc tangent of 0. All students take calculus. Which two quadrants are we allowed to use for arc tangent? A and C. And 0 is just 0, I guess. And where is the tangent equal to 0? At what angle is the tangent of the angle equal to 0? At 0. And I'll go back to our table just a second. So tangent, this is the ratio. The ratio is 0 when that angle is 0 as well. So this one, and so for this one, I would consider that 0. You know, it's really this point, which is 1, 0, which is cosine over sine, and so, or comma sine. And so if we put sine over cosine, it's 0 over 1, which is 0. So our point is right there, and so that one is equal to 0. And so those things that are zeros, ones, and negative ones, we kind of have to think about where that would happen. So the next one is the arc, oh, yeah, and that's right there. Arc tangent of negative 1, arc, or inverse tangent of negative 1. All students take calculus. Same two quadrants that we're allowed to use. Now, when this one, I'm going to get my reference angle for. By the way, which quadrant would it be in, the A or the C one? If it's negative 1 right here. It'll have to be in this C1 because this is when tangent is negative. So it's in this quadrant. So when I get my reference angle, then my actual angle will be negative. My reference angle, at what angle is tangent 1? Pi over 4. So my reference angle is pi over 4, but my actual angle is negative pi over 4. Because for sine and tangent, we just kind of go down that amount. So negative pi over 4 for that one. Then our next one is the inverse cosine of negative 1. So for cosine, all students take calculus. All students take calculus. For cosine, which quadrants do we use? S and A. And when is on the table, when is cosine equal to 1? At 0, and we know at 0 it would be positive 1. So you might think about the fact that it's going to be over here at this other boundary, and so that point is negative 1, 0, and those are always in the order cosine sine. And so for that one, the angle is from, and it wasn't there. It's all the way over there. So our angle is pi. So the inverse cosine of -1 is equal to pi. The next one, the arc cosine of -√3/2. This is probably the one that has the most work. Oh, boy, I was going to do that wrong. Um, all students take calculus. Again, we're allowed to use the first and second quadrant. It's negative, so we're going to be in that second quadrant. And for this one, I have to get my reference angle. What is the reference angle? When is the cosine? At what angle is the cosine equal to square root of 3/2? Pi over 6. So our reference angle is pi over 6 for this one. So that means this angle is right here, but this little piece is pi over 6. So what would the angle be that we need then? It will be pi minus pi over 6. Our actual angle is pi minus pi over 6, or 6 pi over 6 minus 1 pi over 6. So it's what? 5 pi over 6 for that one. The next one, arc cosine of 2. What are we going to do? Well, it's arc cosine. All students take calculus. We can use these two quadrants. Anybody thinking anything about this one? What is cosine bound by? How high, how low can it go? Right, I know. And do you notice how you're not noticing that, right? You know, it's not just always apparent. So the arc cosine of 2, this is not in our domain. Our domain goes from -1 to 1 inclusive, and this is not in the domain, so there is no solution. No solution. And so they should either be on the table, positive or -1 or 0, when we're kind of doing these problems. And then the last one is arc sine, just to kind of reverse ourselves in one like that. And so I'll use red for that one. And all students take calculus. What do we use for arc sine? Which quadrants? A and C again. And this is the arc sine of -1/2. So what quadrant am I going to be in? The C quadrant, since it's negative. And I'll get my reference angle, and then my actual answer is going to be negative. When is the sine equal to 1/2? Pi over 6. There's a lot of, this is a pi over 6 intensive set of problems. And so then really our angle just comes down here. So it's just negative. Our angle is equal to -pi over 6. Pi over 6. Or, excuse me, I said -pi over 6, and then I wrote here -pi over 6. So really, the only time you have to do a lot with the reference angle is when it's cosine or arc cosine, because then you have to kind of find that reference angle. Otherwise, if it's arc sine or arc tangent, it's either the positive angle or the negative angle at that reference angle. Now, there are occasions when we have, and oops, there they are. Oh, there's occasions when we have things like this. So things like this we have to do on our calculator. So find your calculator, and really more than anything, we're just typing these in to check that we can. And you might write on your paper someplace that by definition, the values of inverse trigonometric functions are always in radians, so that you know that we always have to have radians. There's 4 of you, so I will call on each of you once. We'll give you a moment to get those answers. I'll pause it again. Okay, now that we figured those out, let's hear what everybody has. Uh, what do you have for this one, Kate? Negative 1.453. For this one, Sammy, what do you have? And notice I'm putting approximately equal to. Approximately 0.2472. Ben, undefined. Undefined. And for those of you who are gone, just a reminder, our domain is from -1 to, oops, 1 inclusive. And Riley, the last one, 1.927. And so, just practicing on there. So if they are not on that, then we kind of have a direction to go. Okay, so the next thing, and there they are. The next thing is the composition of functions. And all we're going to do today, since we have a lot of people gone, is we're going to write the properties for that. And the book authors call that inverse properties of trigonometric functions. And yeah, to me, that kind of the order is kind of a little funny. So I will make some notes on this. So these are what we're looking at. Remember when we have an inverse, if we take f of f inverse of x, we get back to x. Or if we take f inverse of f of x, we get back to x. And so then these inverse properties of trigonometric functions, the thing we have to be careful of is these only work this way for valid values. So we have to be in that correct place. So if -1 is less than or equal to x, which is less than or equal to 1, and negative pi over 2 is less than or equal to y, which is less than or equal to pi over 2, so we're in that right place, then the sine of the arcsine of x is x, and the arcsine of the sine of y is y. And we can say something similar for cosine and tangent. Again, if we're in that range, or the correct domain from -1 to 1 for x and 0 to pi for y for cosine, then the arc cosine of x is equal to x, and the arc cosine of the cosine of y is y. And then if x is a real number and we're between negative pi over 2 and pi over 2, not including them, then the tangent of the arctangent of x is equal to x, and the arctangent of the tangent of y equals y. One thing I'll say is don't be super fast to just say, oh, look, if it's the arcsine of the sine of something, then it's just going to be that answer. So I also would like you to write that this only works this way for valid values is how I'm saying that. And so that you all want to come back on Monday, I'm going to give you the little, like, what is that, teaser? And I'm going to say, suppose I have the arcsine of the sine of 3 pi over 2. This is not equal to 3 pi over 2. And I want you to think about why that is. And so don't be super quick to just, anytime you see these, to just write it in the other way. I want you to think about why that might be. And I'm going to stop recording, but I might ask why people think it might not be that way.